Good afternoon, all. Am I audible?
Good afternoon, ma'am. Yes, ma'am, you
Yeah.
are.
Okay. And my screen is visible, right?
Yes, ma'am.
Yeah. Thank you. So I will wait for 5 minutes for everyone to join. Then we'll start today's session. Yeah. Again, good afternoon. Since more than 12 has joined, we'll start today's session. Yeah. So today we'll be revising topics from week 2. We'll be seeing topics like KVL, KCL, serial and parallel combinations of resistors, inductors, capacitors, voltage source, and current source. So this is a basic question where we have to find VAB. This is A and this is B, and this V1 is 5 volts and V2 is 3 volts, and with this sign this is VAB. You have to find this VAB. Yeah, you guys try and tell me what is VAB. This is easy, right? Yeah, what
Well,
is
minus 2 volts.
yes. So VAB is minus 2 volts. What is the principle that we applied here? KVL is used here, right? Kirchhoff voltage law. What does KVL say?
Ma'am, the sum of all the potential difference across the circuit is equal to 0.
So
Or
in a closed loop,
potential
increase will be, yeah, right.
potential increase is equal to potential decrease. Ma'am,
Yes.
like I want to ask one thing, like it is minus 2 volt. So can we also give in like 2 volts by considering the opposite convention
Yeah,
or convention solution?
if they are given the direction as like this, then it will be 2 volts, right?
Okay, yes, yes. Okay.
So how will, if I take in this direction the current,
And
so
then it
minus
will be
5
2 volt.
plus 3 will be equal to VAB. So VAB will be equal to minus 2 volts, right?
Yes, sir.
Yeah. So this is a simple question which helps us to understand about Kirchhoff's voltage law. Everyone is clear with this, right? Yeah.
Yes, ma'am.
So we'll move to the next question. So you have 8 volts is connected through a 3 ohms. Then again a 2 ohms is connected in series with 3 ohms. Then there is one 1 ohm in between. Then there is a 6 volt. 4 ohms. So this is IA and this is IB. So please note down the directions of IA and IB, and you have to find IA, IB. You can use mesh analysis. Yeah, take your time. Try solving it and give me the answer of IA and IB.
IA will be 4 by 3.
Give in decimal, no? Round it off to 2 digits.
Sure.
You can either tell the answer or you can also put it in the chat box. Is this the first session for revision? No, actually last week there were 2 sessions that was also for revision sessions only.
Ma'am, I think IA will be 1.65.
IA will be 1.65. Okay, 1 point is right. Okay, you can calculate it again. We have a difference of around 0.5.
Okay, ma'am.
Please put the signs carefully.
Ma'am, is it approximately 1.13?
Yes, IA is 1.13.
IB is 1.217.
Yes, IB is 1.217. Yeah, right. So basically, mesh analysis is we'll be making use of KVL and Ohm's law, right? By the previous example, we already saw KVL. What about Ohm's law? What is Ohm's law?
V equals to IR.
V is equal to IR. So first we'll be writing the loop equations. For loop 1, what is the equation?
8 minus 3IA minus 2IA
Yes.
minus
So basically what I'll write is, yeah, what you said is right. I'll write potential increase in one side and potential decrease in the other side. So that is same as putting 8 minus or equal to, we can also write as 8 is equal to, yeah,
8 equals to 5IA
yeah, 8 is equal to 5
plus
IA.
IA plus IB.
Yeah, it's IA plus IB, right? Because if we see across the 1 ohm resistor, IA is also flowing in this direction, IB is also flowing in this direction. So across this 1 ohm, the total current flowing through it will be IA plus IB. So it is equal to 5 IA. So it's 6
6IA
IA
plus IB.
plus IB. So this is my first equation. What about my loop 2?
6 equals to 4 IB plus IA.
Yeah. So it's basically 1 IA plus IB plus 3 IB. So that is nothing but IA plus 4 IB. Right. So I have two equations and there are two unknowns. So if you equate it, you will find IA is equal to 1.13 amperes, IB is equal to 1.21 amperes. Yeah, do anyone have any doubt in this?
No, ma'am.
Yeah. So this is my first question and this is my second question. So you also have to find the total power dissipated by all the resistors. Find the third part. Find the total power that has been dissipated by all the resistors.
Sum of all power, right, ma'am?
Yes. Find the power dissipated by each resistor individually, then add it.
Question number 2.
So everyone else, did you get the answer for IA and IB?
Yes, ma'am.
Okay. So if anyone have any doubt while finding IA and IB, please let me know.
Ma'am, it's
Show me that.
approximately 16.252.
Yes, it's 16.25 watts.
Ma'am, can you show me once that IA and IP? How do you find it? That
Okay.
equations is correct. I got it, but after that is it?
So I'll write my second equation as it is. It's
Ma'am,
equal to
how
I.
did we get that equation number 2? Can you explain once?
How I got equation number 2, right?
Yes.
So if you see here, the 6 volt is a voltage source. It is giving to the potential increase, right? Also, the current is going
Yes.
from the positive terminal. So we will consider it as a potential increase. So I'm writing plus 6 in this
Ma'am,
side.
we take the direction of the current difference
Yes.
in both loops. We had to take the similar direction.
See, if there is a 6 volt, if the current is flowing in this direction, is it a potential increase or potential drop?
Increase.
Yeah, it's an increase, right? Because the 6 volt is delivering the current. Whereas if there is a 6 volt here and the current is entering the 6 volt, then
Decrease.
decrease. Yeah, right? So this is a potential increase and this is a potential decrease. If you see this equation, where is the current coming out from? It is coming out of the voltage source, right? So it is plus 6.
Yes.
And all the resistors will be, the potential will be, the power will be dissipated. There will be a potential drop across these resistors. So I'm writing the
Yes.
this is under the potential drop thing. So
Yes,
6
ma'am.
volts
Clear.
I already got.
I'm confused because we take the direction of the current opposite from the one another. That's why.
Yeah. Yes, usually the convention is we usually will take IBS in this direction,
Yes.
but here it is given in the question. So that's the difference.
Okay.
So the first equation, I'll multiply it by 4 so that I can eliminate my IB.
Then power will be 16.25.
Yes, 16.25 is right. It will be equal to minus 26. My IA will be equal to 1.13 amperes. This is one method, right? Elimination method. You can use any other method also if you know. Then you can substitute this IA value in equation 1 or 2. So IB is equal to 8 minus 6 IA. It will be equal to 1.21 amperes. Yeah, is it clear? Shall we move to the next question, like next part?
Yes, ma'am.
Yeah. So the next one is we have to find the power dissipated by all the resistors. So there is 3 ohm resistor, then 2 ohm resistor, 1 ohm resistor. Again there is a 3 ohm resistor. So what is the power dissipated across the 2 ohm resistor? What is the formula for power?
I square R.
Yeah, it is VI
Or
or I
IV.
square R
Yes.
or V square.
R V square by R.
Yes. Here, since we know the current value and the resistor value, I will be using I square R. So across the 2 ohm, what is the current that is flowing?
1.1.
Yeah, it's IA. So IA square into 2. So 1.13 square into 2. So you will get one value. Then in the same way, you have to find for 3 ohm resistor. You will get one value. What is the power? What is the formula for power across the 1 ohm resistor?
IA plus IB whole
Yes.
square.
The current through the 1 ohm resistor is IA plus IB. So IA plus IB the whole square into 1 ohm. Then the power through the again this second 3 ohm resistor. This is the fourth one and this is the first one. So it will be IB square 3. So and if once you get total power, it will be equal to the sum of all the powers dissipated by each resistor. You will get the answer is 16.25 volts. Right? Is it clear?
Yes, ma'am. Can you tell me, ma'am, how did we get that power across 3 ohm? It will be helpful for me.
How to find the power across it? Yeah, if you yeah, this is a 3 ohm resistor, right? And IA is the
Yes.
current. This is the current that is flowing in this direction, no? So IA is the
Yes.
only current flowing through the 3 ohm resistor. The formula for P3A is I square R, right? Here the current
Yes,
is
ma'am.
IA square. The resistance is 3 ohms.
Muralidharan, please switch off your.
Okay. Just multiply then and we get the answer.
Yes.
Yes, ma'am. Thank you.
You just
Ma'am, can you
multiply.
scroll a little up, ma'am? I just wanted to write that solution. Yeah. One second. Ma'am, this when you multiplied the equation by 4, you got 32 is equal to 24 IA plus 4 IB, right?
Yes.
And
To cancel it out, I have to subtract this equation and this equation, right? My aim is to cancel
2
out
minus, okay. To do that, you have done this. Okay.
4IB. So I'm subtracting both equations so that
Subtracting those equations. Okay.
my
Thank you.
result will have only one term.
Okay. That's what I was looking at. Thank you, ma'am.
Shall we move to the next question? Do anyone have any doubts in this? Yeah, we'll move to the next question. So there is a node N. I1 is the current, 3 ampere. I2 is equal to 2 ampere. I3 is equal to 4 ampere. Find I4.
Ma'am, it will be 1
1
ampere.
ampere.
1
Yes,
ampere,
it's
ma'am.
1 ampere. So what is the principle that we have applied here?
KCL.
Sum
Yes,
of
it's to
current
current.
incoming is equal to sum of current outgoing.
Yes. Indian node, sum of incoming current will be equal to sum of outgoing current. So at a node, sum of incoming current will be equal to the outgoing current. So here I1 and I2 are the incoming currents, which will be equal to I3 and I4, which are going out. So 3 plus 2 will be equal to 4 plus I4. So I4 will be equal to 5 minus 4 will be equal to 1 amperes, right?
Yes, ma'am.
with this, we'll move to the next question. Perform nodal analysis. Find PA, VB, I. Yeah, find the answers.
Ma'am, I will be 0.18.
Yes, I is equal to 0.18. Right.
And ma'am, VA will be 3.6.
No, V is not 3.6. Please try again.
No, ma'am, it will be 1.4.
Yes, it's 1.4.
And ma'am, VB will be 1.
Yes, 1 volt. Yeah. What is nodal analysis? So nodal analysis will basically be using KCL and Ohm's law, right?
Yes,
ma'am.
ma'am. Basically, nodal equation we have to write at the node VA, na?
Node. Yes, we have to write the equation at a node. At VA, we'll be writing the equation. So let me take so I'll take VA as my node at VA. So I'll take this as IA. So let this current be IB and let this current be IC. Okay, so there are three currents now. Since I have assumed IA, IB and IC are moving out of the node. So by KCL, the sum of current
Direction of current is given na.
that I can, that is my assumption, right? Now I know IA is equal to minus I. You can write it out anyway.
Okay.
IA plus IB plus IC. So what is IA? Since we know by Ohm's law, I is equal to potential difference by resistance. So IA will be VA minus 5 divided by 20, right? Do anyone
Yes.
have any doubt?
Yes, ma'am.
Yes. So IB
Higher
will be,
potential minus lower potential.
yes, VA by 10. This will be VA and 0 by, what is the resistance that will come here? It's
25.
35. Yeah.
It's basically
25,
25 plus 10. There are two resistance, no? See, VA is
Yes,
here.
yes, ma'am. Yes. In series. That's okay.
So basically nodal analysis, we will first identify the nodes. Here it is VA and there are only two nodes. So one node I will take it as a reference and another node I will mark it as unknown. Then I will mark the current direction. Then I will write the equation. Then apply the values for the currents. Then here I have one equation and one unknown. So if you solve, you will get VA is equal to 1.4 volts, right? Since I know VA is equal to 1.54 volts, now I can find I, right? What is the formula for I?
V by R.
Yeah, it's V by R. V is the potential difference. Since the current is flowing from this 5 volts to this VA point, so 5 minus VA by 20. So if you apply, I will get 0.18 ampere, right?
Yes, ma'am.
Then now I have to find VB. So VB is nothing but the current flowing through the resistor 25, that is IC, into the resistance. IC we have to find into resistance is 25 ohms. What is IC? IC we have already found here, right? IC is VA by 35. VA by 35 into 25. If you apply, you will get 1 volts, right? Do anyone have any doubts in this question?
Ma'am, I want to ask one thing, that if when from one thing, that if the direction of the current is given, then we had to use that direction.
Yes. If the direction of the current is given, then you have to use that direction.
And ma'am, the 5 volts above
Wait,
the
one second.
direction of I is given, that
So in this, if since the direction of current I is given, I am taking it like this, right? Since this is I.
yes.
Now how will I write my mesh
Yes.
equation? I is equal to IB plus IC, right?
Yes.
IB and IC will be same. VA by 10 plus IC will be VA by 35. This is 25.
25, yes.
Now, what about my I? I is flowing from 5 volts to VA. So, potential higher potential minus lower potential
Lower potential.
divided by 20, right? So, if
Yes,
you
ma'am.
take this equation and if you check with this equation,
Yes. Both are similar, but this way is easy because we had to take all the things 0 is equals to.
Yes, that's your wish. You can take anyway.
Okay.
So yeah, if I bring this term to here, you will get this equation. So both are same.
Yes, ma'am.
Yeah. Till now, any doubts? So basically, we have seen KCL, KVL, mesh analysis, nodal analysis, and Ohm's law, right?
Yes.
So this is a VA characteristics of which component?
Resistor.
Resistor.
It's a resistor's VA characteristics graph. So what is the slope?
Resistance.
Y is equals to mx.
Yeah, y is
Slope
equal to
equals
mx.
resistance.
So my options are, is it R or is it 1 by R? How to find it? So there is
And
a
slope
straight
is
line,
equals. Yes.
and I know the equation of a straight line. What is the equation of a straight line? Y is equal to mx plus c. Since this graph passes through 0, 0, its equation is y is equal to mx. Okay, what is the x-axis? Guys, am I audible?
I.
Current. I.
Yeah, it's I. And the y-axis is voltage. So V is
Voltage,
equal
yes.
to m I. So m is equal to V by I. What is V by I?
Slope of the line.
It's R, right? So the resistance is R.
Okay.
Suppose if it is I in the y-axis and V in the x-axis, what is the slope of this line? Is it R or 1 by R?
M1 by R.
Yeah, again you have to write. Here the y is I and x is V. So m is equal to I by V. So it's 1 by R. The slope is 1 by R. Is it clear? The difference?
Because current is directly proportional to the or inversely proportional to the resistance.
Yes. Current is inversely proportional to the resistance. Yeah.
Okay.
But, and both are the VA characteristics of resistance only, right?
Okay. And my voltage is directly proportional.
Yeah. So the P is equal to IR. Voltage is directly proportional to resistance. Current is inversely proportional to the resistance.
Resistance. Okay.
So if there is a resistance and this is a DC supply given, VDC R I. So if the resistance is small, I will be V is constant.
Resistance is small, then I is large.
Yes. And if R is large,
Then
I
current
will
is
be smaller than that.
small. Yes.
Then this is Pi. So this is a straight line. So this is a VA characteristics of is it a current source or voltage source?
Current source.
Is it a current source? Write the equation of this line, no? What is the equation of this line? Okay. if this is x, this is y, there is this line. What is the equation of this line? If I tell this is x is equal to 5, the intersection point is 5. What is the equation of this line? It is x is equal to 5, right?
X is equal to 5,
So
yeah.
whatever the values of y, my current x value will be constant. So the equation of this line is x is equal to 5. If I tell this value to be some 2, here what is the equation of this line?
V equal to.
Yeah, the equation of the line is V is equal to 6. That is, the voltage will remain constant irrespective of the current. Voltage is constant irrespective of current. So what is it? Is it a voltage source or current source? It's a voltage source, right?
Voltage source, yeah.
So your ideal voltage source, whatever the current that flows through it, the voltage will remain constant. That is the ideal voltage source, right?
Yes, ma'am.
And ma'am,
So
what
this is
will we get here? Like if we are above, we show that we seen that the slope of the line gives us an resistance, and what we will get here?
so yeah, that's a nice question. So this is an ideal voltage source, right? That point you have to consider. And what is the slope here?
Ma'am, infinity.
Is it infinity or 0?
0.
It is 0, 0.
So what is the resistance of an ideal voltage source? You guys can-
Infinite.
Is the resistance of an ideal voltage source infinite or 0?
Infinite.
Please check, no? Check and tell.
For voltage.
What is it?
Infinite.
What is the internal resistance of an ideal voltage source? It's 0. Search, no? Search and tell. If you once you search, you will feel
Yes,
so sure.
ma'am, it is 0. Ma'am, but
So-
like, for example, slope is basically 10 theta. So here the angle will be 90 degree. So why it is 0?
Slope is dy by dx, right?
Yes, ma'am.
Uh, 1 second. For a straight line intersecting the x-axis, the slope is 0. Okay, yeah, 1 second. Yeah. This by the end of this class, I will clarify it. Okay,
Okay, ma'am. Okay, ma'am.
Okay.
yeah. Again, if there is a yeah, okay. So what is this? This is the VA characteristics of a
Ideal
Current
current
source.
source.
yes, ideal current source. Because whatever the voltage value varies, the current
Is
flowing
parallel
through
to
it
the yes. Voltage is constant.
yes.
Ma'am, if it is parallel to the voltage, then it is ideal current source, and if it's parallel to the current source, then it is ideal voltage.
Yes.
Okay.
Okay. Yeah. Then, if there are two resistors connected in parallel, RA, RB, What is the equivalent resistance?
Ma'am, RA into RB upon RA plus RB.
R plus RB, yes.
Yeah. So it's 1 by RA plus 1 by RB, the whole inverse, right?
Whole inverse, yes, yes.
What if the same RA, RB are connected in series?
RA plus RB.
It's RA plus RB. What if two inductors LA and LB are connected in parallel?
Same like resistors, ma'am. Will be also
LA,
LA
LB by
into
LB.
LB, LA plus LB, yes.
If the two are connected in series,
LA plus LB.
LA plus LB. Suppose if there are two capacitors connected in parallel, C equivalent will
C1
be
plus
equal to,
C2,
yeah, CA plus CB, yes. What if the same capacitors are connected in series?
1 by CA plus 1 by CB.
Yes, CA CB by CA plus CB. Or we can also write it as 1 by CA plus 1 by CB, the whole inverse, right?
Oh, yes. Yes.
So yeah. This, 5U, 3U, 1U, 20U, 12U. Find REB. You have to find the equivalent resistance REB. What does the
Yes.
circuit look like?
Wheatstone bridge.
Ma'am,
Balanced
Wheatstone
Wheatstone bridge.
Yes. So Wheatstone bridge. What are the two types of Wheatstone bridge?
Balance and unbalanced.
Yes, balanced and unbalanced. What is the condition for balanced?
R1
3 by
upon
5 should equals to
R2
12 by 20.
equal to R3 upon R4.
Here, 5 by 20 is 1 by 4. 3 by 12 is 1 by 4. So,
It will be 9.37.
yes, right. So this is a balanced Wheatstone bridge. So if it is, what does that mean? If it is a balanced Wheatstone bridge?
Ma'am, if it's balanced, then we had to remove that 1 ohm resistance, and we can see that both are in parallel.
Yes, right. The
3 ohm and
balanced
12 ohm
Wheatstone
is in
bridge
series,
says
and 5 ohm.
the current flowing through this branch is zero. So basically, the potential at this point and this point are same. So there will be no current flowing through the circuit. So my equivalent circuit will become
5 ohm and 20 ohm is in series, and 3 ohm and 12 ohm is in series, and both are in parallel with them.
so since these both are in series, we will add and 25. Since these both are in series, it is 15. And now my equivalent circuit will again become 25, 15. So this is parallel. We apply the formula for parallel resistors combination and then RAB will be equal to 9.375.
Yes, ma'am.
Right?
Yes.
Any
And ma'am,
doubt?
how to find if the our Wheatstone bridge is unbalanced? Then how to find the voltage and current across that middle?
Yeah, see, if the same circuit is given but some other values which makes it an unbalanced circuit, so my circuit will be like this, right? If I want to find I, apply mesh, no? I1, I2,
Yeah,
I3,
ma'am. Just consider the
three
loops. Yes.
equations. You can also apply nodal analysis also. There are 4 nodes. One node you will make it as 0 volts. Then write the 3 node equation. Then you can solve.
Okay.
Right? For
Yes.
unbalanced bridge, you can either use mesh or nodal analysis.
Yes, ma'am. So I'm thinking is the main part of that till week 3 and week 4 is our KCL and KVL.
Now, can you please repeat?
The important topic is ma'am KCL and KVL until week
So the
3
main
to
focus
4.
of this course is circuits. But it doesn't mean
Yes.
like you will not get questions from third week and fourth week. Okay? You can
Okay.
expect more questions equally from all the topics. But more
Okay.
weightage will be for the week 2 lectures.
Yeah, are circuit type questions.
Yes, circuit type questions. If there is a capacitor, if this is the voltage and current flowing, voltage across the capacitor is V and the current flowing through the capacitor is I. What is the formula for I? C dV by dt, right? I is equal to C dV by dt, right?
Yes.
What is Q?
C by CV.
Yes. I is equal to dq by dt. Q will be integral of I dt, integral of C dV by dt. C I will take it out, dV by dt. This and this will cancel, so C. Right?
Yes.
What is V? 1 by C integral I dt. Right? What is the energy stored in the capacitor?
CV
Of CV
square.
square.
Then these formulas are also important, or only Q equals CV is important?
You can know all the. Yeah, you can also get questions like what is the they will give you the voltage across the capacitor and the capacitor value. They can ask you to find the energy stored in the capacitor, right? You can expect all type of problems.
Ma'am, can
Okay.
we take the one example of it?
Yeah. Uh, Same type of question has been given in practice assignment also, right?
Okay. But it will be helpful, ma'am, if we perform here.
Okay, I will give you the same question from practice assignment. Then we can
And
solve it
then
together.
this note slide you will give now.
Yeah, yeah. It will be uploaded under supplementary contents. No? There is a session called live session notes. Under that, it will be
Okay. Ma'am,
uploaded.
did you have a notes until week 4
Yeah, I
prepared by
have already
you?
uploaded.
No, ma'am.
Yeah,
This PPT is not. I'm not talking about that PPTs. Uh,
then
I'm talking about notes. Did you have any notes
notes.
prefer?
No, till now
Okay.
notes has not been uploaded actually.
Okay.
But after each week there will be a survey session. That notes have been uploaded
Okay.
in there, so you can refer that. So it basically has all the topics summary.
Okay, ma'am.
Will
Thank
the
you.
week 4 content come in the exam?
Yeah, you can expect questions from that also.
Will the assignment solutions be released after the deadline?
Yeah. So till week 3 the deadline has been over. Week 4's deadline is today, right?
Yes.
So yeah, after today, maybe by tomorrow, all the solutions will be uploaded in the portal till week 4.
Okay, ma'am.
So So yeah, if I give the same capacitor value as 10 microfarad and voltage is 10 volts, find the energy.
Yes, ma'am.
Find it in
Just
joules.
put the value of capacitor and
Yes,
into multiply with the value
square
of
of the
voltage
voltage.
square. Yes, and take the half of it.
Yes.
Ma'am, I think it will be zero point 0.5 millijoule.
Yeah. Millijoule. Yes. Right?
Yes, ma'am.
So in the similar way, shall we see about inductors also?
Yes, ma'am.
So this will be 9th part. So there is an inductor and the potential across it is V and the current flowing through it is I and L be the inductance. What is V? It is L di by dt, right?
Yes.
I will be 1 by L integral V dt. Then what about the energy stored in the inductor? It will be of Li square, right?
Half Li square. Yes.
Yes. So these are the questions based on inductors. So we'll solve one question from capacitors. So this is C1. This is 2C1. This is 3C1. Voltage is 15 volts and the charge flowing through it, Q total is 135 microcoulombs. Find C1 and C equivalent. Yeah, try and tell me the answer.
What is QT? It is
Q is the
charge.
total charge flowing through the circuit.
Okay.
What is the C equivalent? The capacitors are in parallel, right? What is the formula?
And basically, it will be 6C1.
Yes, C1 plus 2C2, 2C1
2
plus
plus
3C1.
3.
So it is 6C1. So this is one equation. It has two unknowns, C equivalent and C1. Now I have another one, two data. I have QT and 15 volts. So there is one formula, Q is equal to CV. Since I'm taking total charge, my C will be C equivalent, right?
Yes, ma'am. Ma'am,
Yes.
I think C1. C1 will be 1.5 microfarad.
Yes. Yes, right. What is my C equivalent?
9 microfarad.
Yes, it is 9 microfarad. So C1 is equal to 9 by 6 microfarad. It will be nothing but 1.5 microfarad. Is it clear? Do anyone have any doubt in this question? Yes.
No, ma'am.
K7 has raised his
Yes. Yes. We can discuss the cubic problems, cubes, resistive cubes of different topologies.
resistive cubes of different resistors, right?
Yeah, different topologies like between the faces there is some equivalent distance, and between the edges there will be other equivalent distance. So how to solve those types of problems?
Ma'am, resistive Q is come in exam.
It's included in the portions, I guess, resistive cubes.
Yeah. Now my screen is it visible?
No,
Not visible, ma'am.
Okay. What about
Now
now?
visible.
Okay. Yeah.
Yes.
We wanted to discuss about the resistive cubes, right?
yes, no.
But ma'am, Vishal sir said that the resistive cube is not important as the exam point of view.
Yeah, it's not very much important, but still, it is better to know. Actually, so
Okay.
there is a live session that happened last Wednesday, right?
Yes.
In that live session, I had discussed about three types of combinations of resistive cubes.
Yes, ma'am.
Yeah. So one is,
Can you share the link of that in the chat box?
yeah, sure. So there are basically three types, right? One is
Yes.
from this way, and another is like totally diagonally opposite one. Then under the same face, diagonally opposite, another one is. So there are three types, right? And all these three will be discussed in that live session. I will share you the link.
Ma'am, did you have any other lecture in this week?
In this week, in fourth week, no. Only one lecture has been released under week
Where
one.
is all the lightless links will be available, ma'am? Like, is there any separate file for that?
Yeah. So yeah, one
We are
second. Let me share. Yeah, is my screen visible?
yes,
Yes,
ma'am.
ma'am.
So under week 0, you go under important instructions and links. So in the last, you can see the live sessions link, right?
Okay.
In that, all the session links has been uploaded here, so you can access
Till
it
now,
from.
how what are the classes happened, everything.
Yeah, everything. All the YouTube live links will be updated there. Okay.
Okay. In that, which one is that cube one?
So it happened in this R2 revision session 2.
Okay. Okay. Thank you.
Yeah. Any other doubt?
Ma'am, did you have any calculation tricks for that circuit type of question?
Any calculations?
Tricks like we can save our time during exam.
No. Can you please repeat? I'm not able to get it.
Any circuit problem solving tricks like to save our time. Did you know any tricks like that?
You'll be getting questions from KCL, KVL, and all this, right? You can find
Yes.
whether which one is easier among this.
Okay.
But it all depends on you only. Because either
And
way
I
you
had to
solve,
do
you'll get the
practice.
answer.
Okay.
See, from week
Okay,
1 to week 4, you have like only 1 or 2 methods, right? 2 to 4, 3 methods only you have to solve,
yes,
right?
nodal
As you go,
and that
yes,
mesh.
nodal, mesh.
Yes,
Only 2, right? Yes. So both take the
yes, ma'am.
same amount of time. But if you go to week 5, week 6 and all, there you will be learning new methods like superposition.
Superposition method. Yes.
Yes. So after that, that will be like it will make it will be useful to you to save your time. That will be a little
Okay.
faster. But for me, according to mesh and nodal, both will take same amount of time. So you can learn both.
Okay, ma'am.
Yeah. So yeah. Any other doubts?
No, ma'am.
So, ma'am, tomorrow and day after tomorrow will also be revision classes, huh?
Yeah. Tomorrow did you, if you see in the portal, a mock has been released, right? Mock exam, mock quiz.
Yes.
Yeah. Please go through that. Tomorrow, I think your TA will be discussing the mock assessment.
Okay, ma'am.
And today
Friday
is
will be a
the
last different section.
last date of grading assignment. So tomorrow will be maybe chance to discuss that grading assignment. So
Okay. Yeah. Yeah. Yes. Right. Yeah.
yes.
So yeah. Any other doubt?
No, ma'am. Thank you.
Okay. Yeah.
No, ma'am.
Thank you.
Thank you, ma'am.
Happy Diwali, ma'am.
Yeah. Happy Diwali to you too. Thank you.